Okay, here we go with this example. It says, use the equation provided to answer the questions that follow. The density of oxygen gas is 1.428 grams per liter. Now I look at my equation. Potassium chlorate is decomposing into potassium chloride and oxygen. It appears to me to be balanced. Would you agree? Now, the thing about this, okay, the thing about this is that they give me a density also. Why, oh why, am I given a density? Well, the reason is because, does it ever say that I'm at STP? It does not, okay? So, what I am going to need to do is I'm going to need to calculate a volume using the density. Can I go from moles of potassium chlorate, which they give me, 33 or 3.33 times 10 to the negative second moles. Can I go from moles of that to a mass of oxygen? Can I go from moles of potassium chlorate to a mass of oxygen? I can, absolutely. Okay, so I am going to do that first. So as I come down here, I'm just going to leave that equation up there, but it's telling me I have 3.33 times 10 to the minus second mole of KClO3. Since they've already given me moles, I'm going to go straight to the molar ratio. So I look at my balanced equation, 2 mole of KClO3, 3 mole of oxygen. So now I have converted this into moles of oxygen, correct? Now I need to go to mass of oxygen. Well, I know that 1 mole of oxygen has a molar mass of 31.9988 grams of oxygen. My moles cancel. So what am I going to convert this into now? Should be grams of oxygen. I do my math. I get a value like this. Is that what you got when you calculated it? Yeah? Okay, now why did I not sig fig it? Why did I not sig fig that, Graham? Because I'm not done yet. I want volume, not mass, right? Well, I know that density is equal to mass divided by volume, right? I was given a density up here. And that was 1.428 grams per liter. So, if I go and I substitute 1.428 grams per liter, I just got my mass, didn't I? 1.59834 grams. Can I solve for my volume? I hope so. Okay? So what I'm going to do is I'm going to take my mass, I'm going to divide that by my volume, which is, or excuse me, I'm going to divide that by my density, which is 1.428. And my volume with 3 significant figures is going to be 1.12, and I've got to figure out what my label for volume will be. What is it going to be? Liters. Okay? So why did I use this instead of my 22.4? Density was given. That's the first clue. And why else did I need to use the density? It's not at standard temperature and pressure, STP. Okay? Now, here's a second example. I would like for you to copy that one down, and probably this is the same material up at the top, so just copy down that B right there, okay, and we'll go from there. Okay, here we go. We've got to determine what do we need to find, okay? It says how many grams of KClO3 must react to form 25.1 milliliters of oxygen. This is working almost backwards of what we just did, okay? So the first thing I am going to do is I am going to take my density and solve for grams. I know that density equals mass over volume, so my mass is equal to my density times my volume, correct? My density was 1.428 grams per milliliter, or excuse me, liter, right? Now, here's the thing. I need to convert my milliliters to liters, right? How do I do that? I take my decimal and I jump it 3 places to the left. So I multiply that by 0.0251 liters. As I do so, I come up with a value of my mass is 0.0358 grams, and that's of oxygen, right? That's grams of oxygen, correct? Now, what I need to do is I need to go mass to mass, grams of oxygen to grams of potassium chlorate. Okay? So, flux capacitor that into moles. Come on. My grams of O2 cancel. Now my balanced equation, and I'm trying to remember this out of my head because I can't see it. It was 3 moles of oxygen, right? 2 moles of potassium chlorate. 3 mole of oxygen, 2 mole of KClO3. Now I've converted that into moles of KClO3. My final thing I need to do is find the molar mass of KClO3. Well, I've already done that. My molar mass of KClO3 was 122.5495 grams. KClO3 is 1 mole of KClO3. So when I get my moles to cancel, my final answer is going to be in grams of KClO3. So all I need to do is the math. And when I do so, I come up with 3 sig figs, right?